Good afternoon everyone, myself K. Lakshmi. Today I am going to speak about analysis of feedback amplifiers. So before moving to the analysis of any feedback amplifier, there are certain steps to be followed. So let us see the steps to be followed. First, for the given circuit, identify the feedback element in the circuit. If the output voltage is directly mentioned means connected to the feedback element, it is voltage sampling, otherwise it is current sampling. If the feedback element is connected to base of the transistor, it is shunt mixing, otherwise series mixing. So after identifying the type of feedback amplifier, that is whether it is voltage series, voltage shunt, current series or current shunt, after that you have to find the input circuit. To find input circuit, if it is voltage sampling, make V naught equal to 0. If it is current sampling, make I naught equal to 0. So therefore the resulting circuit is nothing but input circuit. Similarly, to find the output circuit, if it is shunt mixing, make Vi equal to 0. If it is series mixing, make Ii equal to 0. Vi equal to 0 means short the input terminals. Ii equal to 0 means open the input terminals of the circuit. Okay. Then combine the resulting input and output circuits. So after this, replace transistor by H parameter model or approximate model. It is optional. Okay, so we always prefer approximate model because the analysis will be simple. Next, indicate XF and X0 on the circuit diagram. Next, evaluate beta, which is nothing but XF divided by X0. Then evaluate A, which is nothing but what is the gain? So output voltage to the input voltage of the circuit. Next, with A and beta, find D. D is nothing but desensitivity, which is nothing but 1 plus A into beta. Next, gain with feedback, input resistance with feedback, output resistance with feedback, and output resistance with load, with feedback with load. Okay, so these are the steps to be followed for the analysis of any feedback amplifier circuit. Okay, then going to the next slide, analysis of feedback amplifiers. Okay, you can look at this circuit. So this is nothing but actual circuit. So how to, this is nothing but the transistor is nothing but PNP transistor. Okay, first identify the feedback element. What is the feedback element given here? So feedback element is nothing but RE is the feedback element which is connected in between input and output. Okay, and output is directly connected across the feedback element, therefore it is voltage sampling, and this feedback element is connected to the ground. It is not going back to the base of the transistor, therefore it is nothing but what? Series mixing. Therefore what type of amplifier is this? Voltage series feedback amplifier, which is nothing but voltage amplifier. So in voltage amplifier, what is the gain? AV is the gain. Always when we are saying AV, it implies that with source AVS, that is nothing but V naught divided by Vs. In the feedback amplifiers, here AV means the overall gain, that is it includes the source also, it includes the source resistance, therefore AV equal to AVS equal to V naught divided by Vs. Okay, so after finding the feedback amplifier, so now the given circuit is nothing but voltage series feedback amplifier. Now how to find? Actually it is voltage sampling, therefore make V naught equal to 0. Second step, when V naught equal to 0, when I short this one, so RE will be neglected, means RE also connected directly, emitter terminal will be connected to ground. So therefore what will be the input circuit? At the input side you are getting Vs, Rs, and this emitter will be connected to the ground, that is nothing but input circuit. Next, coming to find the output circuit. How to find the output circuit? Since it is nothing but series mixing, you have to make Vi equal to 0. So when Vi equal to 0, so what is happening? Vi equal to 0 means, where is Vi? Sorry, what is type of mixing? It is series mixing, no? Series mixing means II must be equal to 0. When II equal to 0, that means you open the terminals like to the left of base terminal. So only RC and RE will be there at the output side. Then connect RC and RE at the output side. Now join input and output circuits as shown in the figure at the right side. Okay, then replace the transistor with simplified hybrid model or approximate model. Then we will find gain. What is gain? AV equal to V0 by Vs. Then how to V0 is nothing but anyway you are going to get what is V0 here. The current is flowing like this, no? HFE IB into RE is nothing but V0. Vs, how to find Vs? By applying KVL to the input loop. So then you are going to get Vs minus Rs plus HIE into IB equal to 0. That is nothing but Vs equal to Rs plus HIE into IB. When you substitute in the place of Vs in voltage gain, then you are going to get AV equal to HFE RE divided by Rs plus HIE. So after getting AV in voltage series feedback amplifier, what is the input resistance? It increases since it is series, therefore input resistance must increase by the factor 1 plus gain into beta. So RIF equal to what? RI into D. Similarly, what is D sensitivity factor? So D equal to 1 plus AV into beta. So find 1 plus AV into beta. What is AVF? AVF equal to AV divided by 1 plus AV into beta. So we will get AVF value. What is here beta value? Beta value is nothing but V0 divided by VF. So both are at the same positions. Therefore beta equal to I can say no, V0 equal to Vf. Therefore beta value will be equal to 1. So therefore by substituting beta equal to 1, AV as HFE RE by Rs plus HIE, you can find AVF. Then RIF equal to RI into D. So what is RI? RI is nothing but here VI divided by IB. So you will get RI value, substitute, and D you are having 1 plus AV into beta. What is ROF? Actually since it is voltage sampling, therefore it should divide by the factor 1 plus AV into beta. R0 divided by 1 plus AV into beta. So therefore R0 is nothing but for CE amplifier infinity. Therefore ROF equal to infinity. What is ROF prime? It is nothing but R0 prime divided by D. What is R0 prime? When you connect the load, it is nothing but RE. So R0 F prime equal to RE divided by D. In the same way, you can analyze for current shunt feedback amplifier. So you can see current shunt feedback. So this is nothing but current shunt feedback amplifier. So actually the output is not like located at the feedback. So it is other than feedback, it is like means shown. So that is nothing but current sampling, but feedback is given back to the, here what is R prime is nothing but feedback element. So in this feedback element means output is taken at the collector, therefore current and this feedback element is connected back to the input. So current shunt feedback. So following those steps, you analyze the circuit, then find the current shunt feedback means what will be the gain. So output is current, input is also current, therefore current amplifier. Therefore AIF equal to what? AIF equal to AI divided by 1 plus AI into beta. Next circuit is current series feedback. So in the current, so here what is the feedback element? Again feedback element is nothing but RE. So RE, but here output is mentioned at the collector, output is not taken at the feedback element, therefore current, and this is not given back to the base of the transistor, therefore series, current series feedback amplifier. Similarly voltage shunt means here the feedback element is nothing but what? RB. So here output is directly connected to the feedback element, that is why it is voltage sampling, and this feedback element is directly connected at the base of the transistor, therefore it is known as shunt mixing. Therefore what type of feedback topology? This is nothing but voltage shunt feedback amplifier. So following those steps, you analyze the circuit, you find out, that is with A and beta, find out AF RIF, R0F and R0F prime. Okay, thank you students.